Good morning. My name is Matthew McCauley, and I'm with GeoSim Systems, a company that has developed a technology for scanning entire cities at 1 centimeter visual resolution and 5 to 10 centimeters spatial precision throughout the entire city. This morning I'm going to tell you a little bit of a story about how Houdini and GridMarkets solved a problem for us, a fairly difficult, time-sensitive one. I'm going to show you a little bit about our technology. So we had an objective, which was to produce a stereoscopic movie about 1 minute long. We had 12 days notice to prepare this. So I'm going to show you our city modeling technology, talk to you about Houdini and how we used it to do photoreal rendering of our city model, and talk about how GridMarkets played a part in achieving our goal. So the project sequence was the GeoSim city model, moving it into Houdini, taking the Houdini model and rendering it in GridMarkets, and the output in this case was a new type of headset which was partly developed at Lockheed using Fresnel lenses for an extremely wide field of view, 150 degrees, called Wearality. So I'm going to give you a little overview on GeoSim by showing you a movie, and I'll just talk over it so we can understand what's occurring. So it's the first of its kind, 1 centimeter visual resolution everywhere in the downtown core, 15 square kilometers at 1 centimeter resolution. So this is the model. This is a Houdini rendering of it in 2D. And you'll see that there are no cars and no people. Very high street level detail. And we do this by starting with panoramic imagery. We do laser depth scanning using LiDAR units. And we extract the geometry from the city. The result is that we can take this model and port it into Houdini and render it photorealistically in movies, and in this case in a stereoscopic movie is the end result, which I'll show you as we complete. We also run this real time in a game engine so that you can navigate freely throughout the city. It's also an application platform, so you can query buildings, show real-time sensor data. Here we've done flood modeling, which was quite startling for the city of Vancouver to see their cars being covered by water as we actually raise the absolute water level. We're showing a few applications here. So here again, detail continues all the way up to rooftops, and I'll be explaining to you how we do this. It's quite an interesting process. This is a bit of a time lapse where we force the sky and the sun to move. So we're going to talk about how we do this. The company was founded in the year 2000 by Dr. Victor Shankar, and he has developed this process with our team. We start with data collection. We gather from the air using an aircraft that flies low level over the city, using lasers and cameras to gather LiDAR, depth information, and oblique and vertical photographs. So there's an example of some aerial LiDAR, and there's a vertical photograph. That's step one. Takes about 2 days to fly the city generally. At street level, we have a device that looks sort of like the Google car. The difference is the methodology that we use. Google and others use what's called a push broom, where they drive continuously and scan as they go. We use a stop and scan methodology. The process there is that we take a position on the street, we scan 50 million LiDAR points, 300 megapixels of seamless imagery. We move 20 meters, and we do it again. And in downtown Vancouver, we did that 8,000 times. So we have 8,000 stop points, each of which has 50 million LiDAR points and 300 megapixels. It's a lot of data. So now we've got air data for both LiDAR and images. We have ground data. And the next step is that we go indoors. And I'm showing you a little bit here about the geometry extraction. And for indoors, we use a reduced device, smaller. In the future, I imagine this is going to, possibly the model will change, where rather than it being us that does a big store, people will actually scan their own apartments using their depth sensing devices on their phones. But here for the moment is an example of a photograph of an interior that we did at a university and the 3D model that resulted from that. So we have all three sets of data, air, street, and indoor. We have 3 million lines of code that does pre-processing and data fusion. This is an example of a mega cloud of the city that we create. This is just partially constructed where each stop point's LiDAR data is fused together, and then those data sets are fused with the aerial LiDAR. So we then have a mega cloud of the entire city that's continuous and maintains absolute spatial precision of 5 to 10 centimeters everywhere. So once we have all these data collected, we have a modeling production setup. This is all automated so that, and although there are modelers in the loop, they're all connected through a system. This is extremely fast. The output is a 3D city model, and it can be deployed in multiple ways. We can provide the model through a streaming service, or the likely next step is to do real-time cloud rendering delivered with very low latency to a device. So if I am using my phone and I want to turn right, the signal goes to the cloud, it's rendered, and it comes back as a video stream to the phone. Latencies are in the range of 100 milliseconds. That will improve over time. So, and it's platform independent in terms of the destination. So as I mentioned, it's about 3 million lines of code, and it's about 10 times faster than any combination of these traditional techniques, because we've optimized the entire pipeline from beginning to end. Again, this is another diagram of the exploitation process. The important piece here is at the bottom, which is city-related content. So the model is designed in a way that it is not just a pretty picture, it's in fact an application platform. So we can run applications in the city model. If we want to show data from Internet of Things sensors in real time, these can be displayed. We can actually color code buildings to show energy consumption or heat dissipation. As you saw briefly there, we can also run water simulations and so on, so that we're able to provide a different type of what we call more perceptual or nervous system based communication of data. So rather than looking at 2D dashboards with information, you're actually seeing the effect in terms that your nervous system understands very well. Here's one example. In New York, on the left, they did an energy consumption map that was in 2D. We did our own rendering of it to show the distinction that happens when you can then show floors or individual units in a building. It just gives a fine-grained look, also gives a better sense of the activity. So you've seen this list. The obvious applications are virtual and augmented reality. We have Vancouver running in VR now, where you can put on a wireless VR set, move through a motion capture space, and we make the city buildings typically about this high, so you're kind of like Godzilla and you can just walk through the downtown area. You can shrink yourself down to the size of a pedestrian and look up at the buildings, but it's 15 square kilometers of walking, so it's an enormous, it's the largest reality capture of its kind with this level of precision and detail. So moving the model into Houdini. This was our previous rendering in-house that we were doing. And moving to Houdini, and I hope you can appreciate it here we're showing it in 1080 today, but we've done these at 4K and they're absolutely stunning. It's a game changer for the outcome and the perception of the city. The process started with David Clement in Vancouver. His company iZen wrote a pathway for us from our system into Houdini, so that the output was standard HIP files. And I won't attempt to explain it, it's beyond my technical comprehension, so hopefully this little blue box gives an idea that there was good work being done here to provide this in a form that was intelligible. Examples of what interim stages look like. Here we have Root's store on Robson, which actually looks like this in the final Houdini render. But in the interim, you get to see a little bit of the detail that was contained in the very simplest level of geometry. Another example is the Chinatown Gate. And there's the final Houdini render. So now the story we're going to return to is how GridMarkets played a role in our assignment, which is what I described at the beginning. So we had to make a 1-minute movie, which was 1,800 frames at this resolution, had to be stereoscopic, and as I pointed out at the beginning, the destination was a headset which has a very wide field of view with Fresnel lenses and so on. We calculated each frame would take an hour to compute on one of our local machines. We had 6 machines, 1,800 frames, so it would take us 300 hours on our little render farm of 6 machines to do this. And we thought we could get it done, but we had 10 days left and had only 240 hours available to render. So we were thinking, well, we'll scale up, we'll buy a few more machines and try to get this crammed into the time available. But we needed more computers. As usually happens, though, it didn't all go quite according to plan. We began to do some RAM upgrades on the local machines. We had some parts that were incompatible, had a couple of hardware failures. 2 machines had to be pulled out to go for repair. Pressure was mounting. We started a search for suitable machines because we needed to have a certain number of cores and RAM and so on. Couldn't find them in time. And it was very clear we were not going to make our deadline, which was critical for us. It was a major presentation. So from our perspective, we were in a very stressful situation. We didn't have a ready solution. So let me say a little bit about GridMarkets. I'll say some data points at first, but there's a human component to this that's very interesting. So it's scalable computing resources that are Houdini capable, and with an expert staff and a very high level of commitment to solving this problem for us. What we learned very quickly is they have a round-the-clock service. So we were trying to get render into their scalable rendering process. Problems would come up at all times of the day. For us, they had people in multiple time zones able to communicate online in a common chat area, over the phone. And even though we had some issues in preparing our files, they were completely helpful in resolving these issues, and they were able to help us meet our deadline. As they'll tell you, the GridMarkets solution operates inside the Houdini environment. Extremely convenient and stress reducing for our team. I want to talk a little bit about, before we get to the very conclusion of this, about the important distinction that we experienced here. So first of all, the handoff from SideFX to GridMarkets was lovely. They were immediately helpful. They saw the situation we were in. The first contact we had with GridMarkets was one of very careful listening to the problem, and then beginning to lay out how it could be solved, looking at the numbers, looking at the timeline, how many machines would need to be dedicated, how many cores we'd need, what it would take, and then really, really excellent communication regarding how we could solve each individual problem as we were trying to prepare things in the proper form. It was a lovely outcome for us, and I want to show you what this looked like in the end. So what I'm going to show you here is some of the scenes that you saw earlier. We retimed them. We've now split them into stereo fields, so you're seeing left and right eye. And again, at very high resolution and an unusual aspect ratio. The emails that I got back from the client were ecstatic. They were completely happy. It exceeded their expectations. and everything was done on time. So there you are. I think you can tell I'm obviously a very satisfied customer of both SideFX and GridMarkets. They came through for us in solving this problem, and it wasn't a trivial one. So I'm here to answer any questions that you might have and talk further. And we actually have the stereo movies here running in a Wearality headset that I showed at the beginning if you'd like to take a look. So, yes? Yes, he's saying this is clearly Vancouver. Do we have plans to go to other cities? And the answer is yes. The plan is to do the major cities of the world, London, Paris, New York, Tokyo, San Francisco. Interestingly, there are different kinds of drivers for each market. The film community is, of course, always wanting to blow up San Francisco or destroy it in one way or another. So it sort of moves up the list a little bit because of that, that demand. So, thank you.
I would imagine that studios would find these city models at high resolution very valuable. How do you see them being put to use?
So, Mark has said that studios would find these city models valuable. How do we see them being put to use? Well, the value here is that there's a high cost to model inside of a VFX studio to build a very realistic city. It's actually much more cost effective if the city's already been modeled at sufficient resolution. Up till now, cities, and we've all seen the multiple views that are offered, and they're beautiful. They're done from the air where you can move and you get perspective and parallax and so on. The problem is that airborne imagery has its limits. When you get down to street level, everything falls off into a fairly chaotic state. So the power here is that we've actually done all the street level detail. So it provides for pre-visualization. So looking at sets ahead of time, planning, actually being able to measure things inside the model, so you can tell distances and heights and so on. And then afterward, to use the model in perhaps its highest resolution, such as we've seen today with the Houdini rendering, as something that can be, part of a scene, can be destroyed, can be modified, customized. But it's a great substrate, and the hard work has already been done, and it's redeployable. So if we have the model, and you want to shoot a movie that has one theme of, post-apocalyptic, you can set it a certain way, and if it's a fantasy, you can light it another way, so on. Any further questions? Thank you very much.